We'll take a look here at the what's called the discriminant, and it's closely tied in with the quadratic formula. So quick reminder, remember the quadratic formula, we did x equals opposite b plus or minus, and you did a big square root, you had b squared minus 4ac over 2a. Well, the discriminant is the part that's inside the square root. In other words, if you do b squared minus 4ac, and what that's going to tell us, it actually gives us some pretty good information. Um, if that discriminant, b squared minus 4ac, is negative, what happens is this quadratic will have no real solutions but two imaginary solutions. So what that looked like for us, remember, just a quick example there, that would just mean that, the quadratic doesn't touch the x-axis. We've seen that already. If the discriminant is positive, it has two real and no imaginary solutions. So what that looks like, all right, if that's your xy axis, that means that it'll touch the x-axis twice, right? And if it is 0, what that means, there's one real and 0 imaginary solutions. This is what's called a double root, okay? And that's where we've seen this as well. That's just where it'll touch the x-axis, but that's it. So how we're going to use that in this particular case, I'm going to skip over those six real quick. Given the following graphs, determine the sign of the discriminant and if the solutions are real or non-real. Well, first off, for number one, we see that there are two imaginary. And if you look back at the top there, that means that the discriminant, right, so there's your answer for part B. The discriminant is going to be negative because it's two imaginary. Here, sometimes it's easier to answer that second question first. Are the solutions real or not real? Well, there's one real solution, which means the discriminant here was equal to 0. You look at number 3, that quadratic touches the x-axis twice. So we have two real, which meant that the discriminant was positive. And number 4, you can see it touches once, so we have one real. So again, that means that the discriminant equaled 0. So what does that look like for us? Well, let's go back up here and look at number 1. And I'm going to do the work on a separate kind of blank page because there's not a lot of room right here. So the first particular problem, if we take a look here, number 1 was x squared minus 6x plus 11 equals 2. Now, just like before, we want to make sure it's in standard form and equal to 0. So we got to move that 2 over real quick before we move forward. So x squared minus 6x plus 9 equals 0. Now we can move forward with this thing. Good thing to do here, locate a, b, and c. So a is 1, b is negative 6, and c equals 9. So the discriminant equals, so we want the inside part of the square root. So that would be b squared, so we got negative 6 squared minus 4 times 1 times 9. So negative 6 squared equals 36. 4 times 9 is also 36, so the discriminant here is 0. Well, what that tells me is that there is one real solution. So given the following quadratics, how many real solutions? There's one real, 0 imaginary. Now what we can do with that too, if you let me flip back here, let me take you over to Desmos and we'll graph that and you'll see how this plays out. So I've opened up Desmos and I'm going to put in y equals x squared, x squared minus 6x plus 9. And you can see right there, this only touches once. There's one real solution. It happens to be 3, 0. So all of this stuff kind of ties together. But what the discriminant is just one piece of information that we can get a little bit more detail with. So let's take a look at number 2. Number 2 on your sheet. So back to page 24. Number 2, 3x squared plus 5x equals 12. Okay, so let's get this thing to standard form. 3x squared plus 5x minus 12 equals 0. So here we go. A equals 3, b equals 5, c equals negative 12. And what the discriminant again is going to allow us to do is let's just see how many solutions we have. We can start to get a feel for what this graph would look like, if it's going to touch the axis or not. So we want b squared, so we have 5 squared, minus 4 times a, which is 3, times c, which is negative 12. So this is going to be negative 20, or excuse me, positive 25. And then 4 times 3 is 12, times negative 12 is positive negative 144, but that'll turn into plus 144. All right, so for a grand total of 169, that's a positive value, which tells me, for number 2, that I had 2 real and 0 imaginary solutions. All right, let's take a look at number 3. So number 3 is 3x squared plus 48 equals 0. So this is a little bit tricky because it doesn't quite look like it's in standard form. However, we've got an a here, and the c is 48. What we're missing is the b term. Well, actually, since it's not there, we're just going to call it 0. So let's go over here. We can find the discriminant of this thing. So the discriminant, b squared. So we have 0 squared minus 4 times a times c. So at this point, 0 squared, we know that's 0. So we have 0. And then 4 times 3 times 48 is 576. So the discriminant here is negative 576. Well, that would be negative, which tells me that I have 2 imaginary solutions for number 3. So again, if I go over to Desmos, like I was doing before, I can take a look at this. So my equation this time, y equals 3x squared plus 48. The original graph, I don't see anything, so let me zoom out, zoom out, zoom out. There it is. And sure enough, this thing doesn't touch the x-axis, so I have 2 imaginary solutions. All right, let's do the last the last 3 on this particular page very quickly. We'll just kind of walk you through all those. So, and then I'll probably leave all my answers to those 3 problems right here on this page. So we have x squared minus 27 equals 0. So again, it doesn't quite look like it's in standard form, but it is. A here is 1. There is no b, so we'll put 0. And c equals negative 27. So the discriminant, b squared, 0 squared, minus 4 times 1 times negative 27. So we have 0. And then 4 times negative 27 is negative 108. When you subtract the negative, we end up with 0 plus 108. So that's 108. That's positive. So there are 2 real and 0 imaginary. That would go on the blank on your page. For number 5, x squared plus x plus 1 equals 0. So a here is 1, b is 1, c is 1. So we have b squared, right? The discriminant equals b squared minus 4 times a times c. So we have 1 minus 4, negative 3, which tells me I have 2 imaginary and 0 real solutions. And then the last example on your page there, before you try some of these on your own, x squared plus 4x minus 1 equals 0. So a equals 1, b equals 4, c equals negative 1. So b squared minus 4 times 1 times negative 1. So we have 16 minus negative 4, which turns into 16 plus 4. Right, so the discriminant was equal to all this. So it ends up being 20, which is a positive number, which tells me I have 2 real solutions. Whoop. I don't know why I just circled the real. So there are 2 real, 0 imaginary solutions. So one more time, just so you can see it, if I flip over to Desmos, I graph this thing, y equals x squared plus 4x minus 1. There again, you can zoom in and see there are 2 real solutions which is exactly what the discriminant told me I would get. Notice the discriminant doesn't tell you what those roots are or what the solutions are. It just kind of points you in a direction of, okay, there are two real solutions out there.